In this video, I'll talk a little bit about the intuition behind how the EUAC is changing over time, then put it into a project selection context where we're comparing alternatives, and then work an example. All right, remember that the economic lifetime is the time that minimizes the EUAC. If we look at the equation for that, that's based on the total marginal cost, and then look at the components of the total marginal costs themselves, we can see why it's not trivial to figure out what the economic lifetime is going to be. If you look at the first three terms in the total marginal cost equation that relate to how the market value is changing over time, what you can see is that those three terms collected together are probably going to decrease over time. If we go back and think about depreciation and how the market value or the book value changes over time, then the first two terms, the difference between the market value from year to year, is either going to be the same if you're using straight line depreciation, or it's going to get smaller and smaller over time if you're using a declining balance method. The market value itself is also going to be shrinking over time, so that third component associated with the opportunity cost is also going to go down as time moves on. So collectively, the first three terms are going to go down, but we said that typically the expenses, the last term in the equation, are going to go up. And so as we're adding each additional year of total marginal costs and then averaging that out over the entire time period, we can kind of see that intuitively the EUAC can probably decrease initially for a few years, but then eventually, as the first three terms get smaller and smaller and the expenses start to ramp up, that over time the EUAC would turn around and start increasing again, further towards the end of life. That's quite common to see a one-year economic lifetime for defenders. By the point where we're thinking about replacement, an asset might already be old enough that things are just going to keep getting worse from here on out. And we're really just waiting for something better to come along to replace it with. So when we're thinking about challengers, we want to know what's the EUAC of the challenger over its economic lifetime. And that's what we want to compare to the EUAC, or the total marginal cost of the defender. If the EUAC of the challenger is still greater than the EUAC of the defender at any point in the future, then we wouldn't change to the challenger, because we're trying to minimize the average annual expenses over our entire planning horizon. When we start comparing defenders and challengers in a replacement analysis, we need to make a few simplifying assumptions. First, we assume that the challenger is always going to be used for its economic lifetime. Therefore, it minimizes its own EUAC. We then assume that the challenger is going to have that same annual worth no matter what time period we implement it. So in other words, we're assuming that the cost of the project doesn't change if we delay it. And then finally, we're going to assume that the challenger is the best possible challenger. So we may have a step beforehand where we need to figure out what that best challenger is. And that would be a standard project selection exercise, except for the fact that now we're going to compare them on an annual worth basis, assuming that each potential challenger is used for its own economic lifetime. If different challengers have different economic lifetimes, then we have the same sort of situation we had before, where the project selection process has to account for the fact that we have unequal lifetimes. In this context, the different alternatives that we want to compare are different combinations of defender and challenger that vary according to when we replace the defender with the challenger. Before replacement, the cash flows that we're going to assign to the cost of this combined project is going to be the total marginal cost associated with the defender for each year. And then once we replace the defender with the challenger, then the cash flows in each future year are going to be represented as the annual worth of the cost of the challenger. Therefore, the decision we need to make is when to replace the defender with the challenger. And we're going to make that decision by minimizing the total costs over the entire planning horizon. So what we're going to do is we're going to choose the time period that minimizes the total worth of cash flows associated with both defender and challenger, including the possibility of having to repeat the challenger depending on whether its economic lifetime is greater than or less than the length of the planning horizon after we replace the defender with it. To test whether you understand the implication of this, try looking at this question and answering it before you move on. Okay, are you ready? The question asks, when should we replace the defender with the challenger? We know that we can represent the challenger using the annual worth of its costs, or the EUAC. Therefore, we want to switch to the challenger whenever that annual cost is less than the annual cost associated with using the defender. We want to swap out any year that we can where the annual cost of the challenger is less than the annual cost of the defender. Therefore, it's not really the EUAC of the defender that we care about. It's the total marginal cost from year to year. As soon as that total marginal cost of going one more year with the defender would mean that that year has a higher cost than if we switch to the challenger, that's when we want to make the switch. Therefore, the answer here is B. There is, however, a bit of a caveat on that answer, and we can illustrate it by looking at this example problem. Read over it, pause the video, and try and work it yourself. Then we'll talk through it.
Let's go out to the kitchen. Let's go out to the kitchen. Let's go out to the kitchen and have ourselves a snack.
Ice cold milk. Help yourself.
And we're back. So, we have this problem where the centrifuge could be kept operational for another 4 years, or we could sell it now for $3,500 and replace it with a new model that costs $5,000. That's our challenger. We've got this table that has the market values over time for the next 4 years, and we're told to use a hurdle rate of 10%. So the first question that we're asked is, what's the economic lifetime of the challenger? To do that, we need to find the EUAC of the challenger and figure out how many years minimizes that quantity. That'll be the economic lifetime. And then we want to ask when the defender should actually be replaced. To figure this out, let's put all the information from the problem into an Excel spreadsheet. As always, I'll post this spreadsheet on Blackboard and Google Drive so that you can examine it in more detail and so that you'll have an example to modify for homework problems or for the case study. We'll focus first on the challenger here at the bottom in order to figure out its economic lifetime. I've got a column here where we're calculating the EUAC. That is just the annual worth of all of the costs, and so we could divide this up into the annual worth of the O&M costs plus the capital recovery amount, where, remember, the capital recovery amount is the annual worth of the difference between the initial investment, or MV sub 0, and the market value at any given point in time. As you can see, the EUAC is calculated for each year that's a potential useful lifetime, and it's minimized after 2 years. So therefore, the economic lifetime of the challenger is only 2 years. Now, we want to know when we should replace the defender with the challenger. To figure this out, we know that we can represent the challenger by the annual worth equal to the EUAC of its economic lifetime. So we're going to take this 2776 and we're going to compare it to the EUAC of the Defender as well as the total marginal cost of the Defender. In that previous question that I asked you, we said that we would replace the Defender as soon as the total marginal cost of the Defender is greater than the EUAC of the Challenger. So if we look at the total marginal cost column for the Defender, we can see that that's true immediately. The total marginal cost in the first year of additional use of the Defender is $3,200, which is greater than the 2776. So ideally, we would think we should replace the Challenger immediately. However, this is the caveat to that question. We can see the total marginal cost 1 year later is actually less than the EUAC of the Challenger. So we need to ask ourselves then, well, if we stick with the Defender a little bit longer in order to get this total marginal cost that's less than the EUAC of the Challenger, does that actually allow us to bring down the EUAC of the Defender enough for it to be momentarily lower than the Challenger? If we look at the EUAC associated with keeping the Defender for 2 more years, we see that in this case, that's not true. The EUAC is still greater than the EUAC of the Challenger. So even though the total marginal cost, if we held on to it a little bit longer, could be less than the Challenger's EUAC for 1 year, it's not enough to bring the average over the first 2 years lower than what it would be if we replace the Challenger immediately. So in this case, that means that our original decision is still correct, and we should replace the Defender immediately.
Hey, what's going on, Spice Lords? This is
Doc Johnson.
checking in to say thank you for watching today's episode. It's been a childhood dream of mine, long before YouTube was invented, to one day have a
100
subscriber channel, and we're pushing it. We're getting close. Help make this fully grown adult man's dream come true. Who appreciates you, Spice Lords? I do.